Good afternoon, everyone. I am Raghavan, and my last name is Muthu Regunathan. It's difficult to pronounce, and I was just telling every time when I come into US, the officer at the immigration always finds difficult to say Muthu, and I say, officer, please go with the last name. That's easier to pronounce. So it's fine. What I'm going to talk about today is unlocking LLMs for billion more prompt engineers. So before that, a little bit about me. I'm a senior manager at LinkedIn. I'm also an open source contributor. I volunteer for UN's ITU disaster management group, developing search engines for policymakers within UN. And it's very easy to get irrelevant these days, given the pace at which AI is moving. So I'm also an avid hackathon participant, and I recommend everyone to look into lablab.ai, which is a very good place to build and participate in hackathons. And I'm a husband and I'm a dad to 7-month-old. Before this, I was at Microsoft Bing Search, Foursquare, before I moved to LinkedIn. And I have the GitHub link in the presentation, so anything that I say is reproducible, feel free to go ahead and reproduce it. And I worked on with a few folks. The good thing about open source is, if you build something and put it out there, folks who are like-minded and are interested are going to contact you and you can build on top of it. So I collaborated with Amrita, Arjun, Shyam. I don't even know these people until I put that out and and they reached out to me to work on this mini project. Amrita from Amazon, Arjun from Tableau, and Shyam from Meta. So the agenda for today is, I'm going to talk about LLM usage, specifically ChatGPT. And what if the prompts are not in English? There are problems with GPT today. I can show you examples when the prompt is not in English. And we found the reason for it, and we have a really low cost or no cost solution for that. And we are going to compare the cost of the standard solutions of fine tuning versus the solution that we have, and the business opportunity that it unlocks. So remember the title of unlocking 1 billion more prompt engineers if we can make GPT good for languages that are not English. So from similarweb.com, GPT usage, LLM usage, specifically ChatGPT, 15.3% of users are from US, 7.2% of users are from India. And you can see that it's not just US that's using ChatGPT, and a lot of users are from outside of the US. And how many of you use ChatGPT for various different reasons? Some of the, yeah. And people use it for general knowledge, like what is the surface temperature of Sun, Mars, etc. I have seen my friends use ChatGPT for their kids' homework help, like help me write an essay for algae and fungi, life advice, how to improve mental health, very important nowadays, and creative writing write a short essay about something like unicorns and dragons, and sometimes procedural questions like how do I brew something, like say a step-by-step method for brewing a green tea or black tea. Why are people not using Google? I mean, people are still using Google, but are using ChatGPT for this. It's because of their ability to follow instructions, and it's phenomenal. The instruction following capability of LLMs is what make people use GPT or any large language model. I don't want to single out GPT. Claude is also equally good, as opposed to well-known search engines out there like Google and Bing. But what if the prompts, okay. So this actually led to prompt engineering as a profession in itself. You may have heard of these types of prompting techniques, chain of thoughts, which is nothing but provide a step-by-step instruction of what is it that you want from GPT, or contrastive chain of thought where you give a positive example and a negative example and then ask GPT what is that you want from it, and then take a deep breath. How many of you know about this? Okay. Take a deep breath is nothing but if you just add the phrase take a deep breath at the beginning of your prompt, the LLM response quality is much better. And then emotional prompting. I have used this personally myself, where I say, hey, whatever that you say, my life depends on that. So could you give me the right answer? And there are many more. Again, I want to call out that the instruction following capability of GPT is what is driving this new field of prompt engineering. And what if the prompts are not in English? So we did this study of, we tried languages that are not English. We chose South Asian languages and Middle Eastern language. And we used Google Translate to translate our English prompts to the corresponding prompt in that target language. And then we prompted GPT 3.5 because that's free of cost. I don't have to pay $20 a month. We compared the instruction following capability of GPT 3.5 in that language and the quality of response as opposed to corresponding English language. So first, write 3 paragraphs of 4 lines each about the solar system. You can clearly see that it's exactly 3 paragraphs and there are 4 lines each. I have color-coded the dot. And it's following the instruction. Great. 3 paragraphs, 4 lines. What if we ask the same question in Arabic? I'm not a native Arabic speaker. I rely on Google Translate to do this. You can see it's not 3 paragraphs, and different paragraphs have different lines. Are there any Arabic speakers in the room to validate this? If not, I trust Google Translate to do the right thing. So, and I compared, and you can see just by the syntactic response that it's not following the instruction of 4 paragraphs and 3 lines. And then, sorry, 3 paragraphs and 4 lines. The same for Hindi. I'm not a native speaker of Hindi, although I understand Hindi. I'm from India. I'm from southern part of India, so I don't speak Hindi. But I do understand Hindi. And I can say that it did 3 paragraphs, but it got the line count wrong. And it was the response quality depending different times. I don't know the seed that's used by GPT 3.5. It varies depending on if you do different instances. There have been instances of poor response quality. Same for Urdu. I'm not a native speaker, but you can see the line count is wrong. 3 paragraphs is good. I'm a native speaker of Tamil, and I can clearly say that this is useless for a Tamil speaker. And not only, it's just 3 bullet points. It's not even 3 paragraphs. And I have the links in the slide deck for you to verify. And so the same thing for several other languages. I chose languages in such a way such that I can carve out 1 billion more prompt engineers. I could have simply used all the languages in India to get 1.3 billion, but some of these languages are very less spoken and the economic value of it could be challenged. So if you take all these highly popular languages in South Asia and the countries in South Asia and Middle East, which is Arabic, Urdu, and these languages, the instruction following capability and response quality is poor. And why? Why is this the reason? It goes back to the training data. What goes in, what goes out, right, in the world of machine learning. So, quoting directly from Wikipedia, GPT uses the Common Crawl data set, of which 46% of that data is English, followed by German, Russian, Japanese, French, Spain, and Chinese, each less than 6%. With this disparity, GPT does not have enough examples to learn for these South Asian and Middle Eastern languages. And there is also an additional grammatical complexity, both in terms of morphology and the language construction, that we may need a specific tokenizer. The byte pair encoding tokenizer that's used by GPT to do the initial tokenizing may not be sufficient. It's just a hunch. I don't have evidence, but I still want to call that out as a reason. So what could be the solution? Let's build an LLM per language. We can do that, but it certainly costs money, millions of dollars. NVIDIA will make more money. They have still more GPU. And the popular solution nowadays out there, if you have any domain-specific task, is why don't you fine-tune? You can certainly do fine-tuning. You can prepare a comprehensive data set for the underrepresented language family. And then you start with the base LLM. You can add low-rank adapters. And then, sure, you might be able to solve the problem for that underrepresented family. But both of these cost money, like tens of thousands of dollars for the fine-tuning. Fine-tuning is much cheaper. It's not in the $1 million range. But if you have to develop your own LLM, it's going to cost much more. Is there a much simpler solution? And there is, we again rely on, this is where when people in the open source try different things, and just by the collective human intelligence, you come up with some really interesting solutions. And what we did is we did nothing fancy. We took the prompt, and we are able to identify the language, asked Google Translate to translate in English, send it to GPT, get it back, translate it to the previous language. That's all. It's near zero cost, or if the Google Translate API costs something, you may have to pay for that, but it's still orders of magnitude less than creating a new language model, large language model for that language, or even if you want to fine tune. And interestingly, we observed this earlier, but we were able to appreciate this only when we developed a demo. So in Arabic, again, I want to live in the solar system example again. I like solar system. So, because I'm on it, I need to write a report about the solar system. What are the different planets? What are some previous planets? Can you write a report of 5 paragraphs, each paragraph containing 4 lines? And we translated that's the English translation. The original thing is in Arabic. Internally, it was translated to English. Without the translation, it's not 5 paragraphs, it's 5 lines, right? And it took 21 seconds, not milliseconds, 21 seconds for GPT to do. The inference time of GPT for these languages are slow, for these underrepresented languages are slow compared to that of English. And we just accidentally discovered, because we introduced some log statements, and then on net we see that GPT is slow without translation for these languages. But when we do translation, it took just 13 seconds. And the response quality is much better. You can see 5 paragraphs, and we actually asked GPT-4 to evaluate these responses, and GPT-4 almost always selected the solution from us as a better response than, maybe there were some corner cases, but 90% of the times our solution was selected by GPT-4. We did not want to rely on human, we wanted GPT-4 to evaluate these GPT 3.5 responses. And GPT-4 selected the translated solution as a much better solution. So as a much better response for quality. So just in Arabic, GPT takes 21 seconds, with translation 13 seconds, and actually honors the instruction. Same for Urdu, you can see 33 seconds, and the quality is much poor. While with the solution of translate to English, do it, and then retranslate, it's actually faster. Same for, let's go to a different example. Preparing a report for your manager or supervisor can cause mental stress. So I took this from internet, where there was, I need to be prepared. When I was researching this emotional prompting that I said earlier, I need to be prepared for a presentation for my supervisor. With my supervisor, I need to reduce my mental stress. Please provide instructions on how to do it. I'm saying it in English, but say that a Tamil speaker wants to actually ask GPT in Tamil. So I'm translating for the purpose of this crowd. And it took 51 seconds to give a completely useless response. I can attest to it because I'm a native Tamil speaker. And that response is completely useless, not just about following instruction, as opposed to the one where we translated to English and we got it in 12 seconds. And the response was much more useful for me as a Tamil speaker. So yeah, 51 seconds versus 12 seconds. The response is not useful. Clearly, it shows there's a need for prompt translation with GPT. So what is the business opportunity here? The business opportunity is large language models are very much English-centric today. And there is an opportunity to unlock this new professional field of prompt engineering to non-English speakers, 2 billion more. If you count the subset of languages from South Asia plus Middle East, it should definitely take 1 billion more professional workers would be able to use LLMs. And you see US is still like 15% of GPT usage from the very first slide. So that opens up that opportunity, and it would actually make the LLM calls faster in its current form. like without having to fine-tune, without having to spend million more dollars to fine-tune or say come up with a new large language model. This is a cheaper solution. That's it. I feel free to ask me any questions. And the GitHub link is there in the slide. Feel free to use it. If you have any questions, you can always reach out to me on LinkedIn. My last name is unique enough that if you search for me, you would be able to get me on LinkedIn. Questions? Yes.
So my question is, even before the translation, this 1 billion speakers are just speaking, right? So you might also have to consider the speech to text first.
I am hoping the OpenAI Whisper is doing a good job. So yes, that goes without saying. I am making that assumption that translation is available. OpenAI Whisper is actually doing a very good job for
Makes sense.
these translation tasks.
So you mentioned approaches from the open source community that you looked at. I was wondering if you have any insight on sort of the performance comparison of your approach versus what the open source community is doing, and also maybe a comparison of what the effort that's required for that, how that compares.
So how many of you know Chip Huan? She is well known in the internet, in the open source world. She did call out, one of the reasons I looked into this problem is I read Chip Huan's article about investing in LLM research for non-English. So there is active effort going on to develop LLMs for outside English, but I think it's a default mentality to go explore building a new LLM or fine-tune, because fine-tuning actually gives you very good results. So there might be solutions that are, yeah, you may have seen that I did not publish any objective numbers of how this is good versus that of fine-tuning, because we didn't do that comparison. But if you ask my, through hunch, I could say yes. Where I think this solution would be, it is cost. You don't have to spend dollars to translate. There are, or it could be just a call to OpenAI first to translate and then to later do this instruction calling. So that is much cheaper. So cost-wise, I think this is a much better solution. But quality-wise, which I don't have numbers for today, that would be a much better solution. Fine-tuning is definitely a direction that people would try.
Yeah, so I'm curious to hear if you have intuition as to the technical root cause for the inference taking so much longer with foreign language.
I have only hunches, but there is no evidence backing it. That's why I did not add. And it's something that we found while we implemented it, like just accidental finding with the log statements. I think it goes back to the token diversity. Because of the training data that is used by GPT from Common Crawl is majority English, there are not enough tokens from these languages, and as a result, the inference is taking slower. That's my guess, but again, I don't have hard and fast evidence to say that's a